are drawn taking two sides of a triangle as diameter, prove that the point of intersection of these circles lie on the third side. Okay, let's understand what the question says. Just a second. Ma'am, we are going to start new chapter today. Yes, Tejas. Okay, we will be starting. Okay, the introduction I'll be giving, hopefully. Let's cover it quickly. So if circle are drawn taking two sides of a triangle as a diameter, okay, circles are drawn, two circles are there. Okay, two circles are there. We don't know both are just separate from each other or intersecting, just like previously we have seen one of the question in the first exercise. Okay, so we will keep both the consideration in hand. Let's see what the question says. If circles are drawn taking two side of a triangle as a diameter, okay, so basically with the help of two circles we are going to draw triangle. Okay, let me check whether this way will it be possible or not. So circles are drawn taking two side of a triangle as a diameter. If I will make the diameter like this, okay, fine. If we will make another diameter like this, okay, maybe here is the center. If circles are drawn taking two sides of a triangle as a diameter, prove that their point of intersection of this circle, point of intersection of these circles, that means we have drawn the circles properly. Okay, because there is a point of intersection of circle. Okay, lie on the third side. Okay, point of intersection, this two, it lie on the third side of the triangle. That's what we have to show. Okay, let me summarize what the question says. We are having two circles. Okay, we don't know whether these two circles are just like this or just there is a point of intersection. Okay, there are two circles, but this part, that the point of intersection of these circle, that means we are having the second scenario. Yes or no?
Yes, ma'am.
Yes or okay. Now let's read it from the very beginning. If circles are drawn, taking two side of a triangle as a diameter. Okay. So in the first circle, there must be a diameter. Okay. There must be a diameter. Suppose this is the diameter. This is the diameter. Okay. In the second circle, there will be a diameter. So basically, in this two circle, we are taking make a triangle with the help of the diameter. Okay, one of the diameter is one of the side of a triangle, another diameter is another side of the triangle. That's how the triangle we are having. Okay, if circles are drawn taking two side of a triangle as a diameter, so basically we are having a triangle. Okay, taking two side of a triangle, suppose AB, we are taking as a one of the side of a triangle, and keeping it as a diameter, we are drawing a circle. Maybe it looks like this. Okay. Then AC is the another side, keeping this side as a diameter, we are drawing another circle. Maybe it will look like, okay. Then we have to show that, we have to prove that the point of intersection of this circle lie on the third side. Okay. Basically, we have to show that the point of intersection of this circle, this point of intersection, okay, lying on the third side of a triangle. Are you getting it? Are you getting it what the question
Yes,
says?
ma'am.
Okay. Rather than starting the construction from the circle, it will be more easier if you will understand with the triangle. Because let's read it. Now it will make more sense. Forget about the drawing the circle and all. Okay. If circles are drawn, how we will draw the circle? Taking two sides of a triangle as diameter. If we are drawing circles, taking two side of a triangle as a diameter, so this side is a diameter, okay, and the other side is also the diameter. Then we have to show that the point of intersection, okay, of this circle, okay, forget about that point of intersection which is lying on the vertex, the other point of intersection, okay, lie on the third side. That's what we have to show. Is the question clear to all of you?
Yes, ma'am.
Yes, Tejas, is it clear? Farhan?
Yes, ma'am.
Okay.
Ma'am, can we
Let's,
take?
yeah.
Ma'am,
Yes,
can we
Sazia.
read?
Yeah, sure. Okay, read the statement. If circles are drawn taking two sides of a triangle as a diameter. Okay, if we are drawing circles, how? Taking two sides of a triangle as diameter. We are having a triangle. Taking two side. Okay, in this triangle, we can see AB side is there, BC side is there, AC side is there. Any two side you take. Okay, any two side. I am taking AB and AC. And by taking this two side, I am going to draw circle. How? I will maintain AB as a diameter. Okay, and then we'll draw a circle. Okay, so maybe our circle will look like this. If I am maintaining AB as a diameter, can you see AB looks like a diameter? Yes or no? Yes or
Yes,
no?
ma'am.
Yes, ma'am.
Yes,
Similarly, AC as a diameter, I am going to maintain this side as a diameter and I will draw another circle. So maybe the circle will look like this. Like this. Okay, we have drawn two circles. First circle is having AB as a diameter. Second circle is having AC as a diameter. Then we have to show that the point of intersection of these circles. So there are 2 points of intersection. Okay, one is this, another is this. The point of intersection of this circle passes through the third side of the triangle. That's what we have to show. Are you getting it?
Yes, ma'am.
yes,
The point of intersection, of course we are talking about the downward one, that is passing through the third side of the triangle. That's what the question says. Okay, let's see what can we do. Okay, let's try analyzing what can be done from here. So suppose we are focusing for now on this triangle, on this circle. And we know AB is a diameter. Just a second, let me check. Just a second, let me draw appropriate figure because this figure, AC is not the diameter. It doesn't looks like diameter over here. Let me draw it properly. It looks like ellipse. Wait. Why it doesn't allow to take the shapes? Yeah, basically it is going to look like this. Okay, it is going to look like this. Now what we will do over here, we know that angle in a semicircle is 90 degree. Yes or no? Yes or no?
Yes, ma'am.
Okay, if angle in a semicircle is 90 degree, then can we say that this angle, okay, this is a diameter and I am going to create an angle over here. This angle over here, can we say it will be 90 degree? Because angle in a semicircle is 90 degree. Can we say that?
Yes, ma'am.
Similarly, if we will take this diameter, can we say that this angle will be 90 degree? Because angle in a semicircle is 90 degree. Can we? Can we?
Yes,
Yes,
ma'am.
ma'am.
Okay, so this angle is 90 degree, that angle is 90 degree, and we can see from here that 90 plus 90 is making 180 degree, right? Right?
Yes, ma'am.
That means a straight line is getting created over here. Yes or no?
Yes, ma'am.
A straight line is getting created over here. That means point of intersection lies on a, a straight line. That means third side of the triangle. Am I making sense?
Yes, ma'am.
Okay. Angle in a semicircle is 90 degree. Angle in a semicircle is 90 degree. Now 90 plus 90 is 180. That means a straight line angle, a linear pair. That means there is a straight line over there. But we are talking about circle. Hmm? We are talking about circle. How can there be a straight line? That means this must be a side of the triangle, the third side of the triangle. Yes or no?
Yes, ma'am.
Everyone, is it clear?
Yes, ma'am.
Okay, A, B, C. Okay, here you can say D is the point of intersection. Okay, now we know, here we know angle ADB is equals to 90 degree. Angle in a semicircle. TD, that is 90. Angle in a semicircle. Right? Now, from 1 and 2, from 1 and 2, angle ADB plus angle ACD is equals to 90 plus 90. That means 180 degree. Okay. Therefore, therefore, BDC is a straight line. That means the third side of the triangle. That means point of intersection of circles lies on third side of the triangle. Is it clear to all of you?
Yes, ma'am.
Let me check, is there another question like which we need to discuss? Otherwise, I will move
Can
to.
you show the question so I can note it?
Yes, Tejas.
Can you show the question?
Yes, sure. See, rest of the questions, like one or two more are there, which is very simple. Okay, try it. If you can't, I'll be taking it. Okay, the way you asked in between any in like while I'm explaining another concept, the way how you ask that I'm having this problem in this concept or maybe that question, same way practice the whole exercise and let me know if there is any question where you are having difficulty or doubt. I'll be taking it. Okay, even if I'm discussing surface area and volume, I'll be taking questions from here. Okay, and will be explaining you. Today I'm keeping this much from here. I'll be starting the introduction of surface area and volume. Introduction. Okay.
Can you show the solution?
Yeah, sure.
Ma'am,
Yes, they just let me know once you are done. I'm showing it.
yes, ma'am.
Done. From here the solution starts. Let me know.
Yes, ma'am, we can.
Ma'am, just a sec.
Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay. Now, as I said, we'll be starting the introduction of surface area and volume. Okay, so you need to understand the basics at first, starting from cuboid. So, do
Excuse
you?
me, ma'am.
Yes.
Ma'am, the in exam the circle theorems will come to proof. Like, have to prove the theorem.
Yes, Sazia, you was asking how many theorems are there. Yes, I also checked. Total 11 theorems are there. Okay, but actually 11 we have proved, but there are like few like angle in a semicircle is right angle, and this type of like it can come in question. You should know how to prove it, and you know that, right?
Okay. Yes, ma'am.
Yes, yes. Theorem will come in exam. Only questions will not come. Theorem will also come.
And ma'am, from quadrilaterals also midpoint theorem can come, right?
Yeah, from quadrilateral also midpoint theorem can come.
Okay, ma'am. Thank you, ma'am.
Yeah. So yes, surface area and volume. At first surface area. Okay, I'm starting since in our syllabus there is directly the surface area of cylinder and the surface area of cone. Similarly, the volume of cylinder and the volume of cone. This much is there only. Okay, cuboid is not there because you know already cube and cuboid you know already, and you have done those chapters in the previous class. That's why it's not there this time. Okay, so this part is omitted from the syllabus, but in class 10 you will be getting again the same chapter, surface area and volume, and there the combination of shape will be there. Then that time it will not be the case that cube and cuboid is not there. There will be cube and cuboid, and on the top of that hemisphere is there. There is a cube on the top of that hemisphere is there. This type of combined shape will be there. So you need to have a proper understanding of these shapes, including cube and cuboid. Questions we will not be solving from cube and cuboid. We will be following our NCRT, but let's discuss from where the formula came and all. So at first I am taking cuboid. Okay, surface area of cuboid. Can you tell me what is the formula for surface area of cuboid?
Ma'am, length into breadth into height.
That is volume, Sazia.
Yes, ma'am.
क्यूबॉइड का सरफेस एरिया कैसे फाइंड करते हैं? Cuboid is made up of which shape?
Square.
Square or
Ma'am,
rectangle?
rectangle.
Say is rectangle.
Rectangle. Okay, if I will take one rectangle, if I will take another rectangle, okay, if I will make a box like this is a cuboid. Okay, you can see here clearly that there is a rectangle at the bottom. Can you see it? Can you see it?
Yes.
Okay, there is a rectangle on the left side. There is a rectangle on the right side as well, on the top, on the back. Okay, all the rectangle I am going to highlight. Hopefully it will make sense to you. So there is a rectangle over here also. Okay, there is a rectangle at the back.
Sum of all rectangles, I think so.
Okay, yes. Okay,
Sum of all rectangles will be the surface area.
exactly. Surface area means area of all the surfaces combined together. There is rectangle at the top as well, if you can see. Okay, and the rectangle on like in at the front also. Okay, so how many rectangles are there? Who will say?
Ma'am, 6.
6 rectangles are there. Think about it. Rectangle at the bottom, rectangle at the top. 2 rectangle, rectangle on the left, rectangle on the right. 2 more rectangle, rectangle on the front, rectangle on the back. 2 more rectangles. Total 6 rectangles are there. Surface area of this shape cuboid is the area of all the surfaces added together is called the surface area of cuboid, or you can call it total surface area of cuboid. Okay, area of all the surfaces combined together, The formula is, you must have seen the formula. The formula is 2 in bracket, length into breadth plus breadth into height plus height into length. Have you seen this formula?
Yes, I remember.
Okay, from where this formula came? So it came from the concept only. Again, I am drawing a cuboid, and this time I don't need to highlight it because you understood that how many rectangles are there. So yeah, just a moment, let me show it to you from where exactly this formula came, because in question, okay, a room will be there which is in cuboid shape, a hall will be there which is in cuboid shape, and there is like one of the face is missing, one of the side is missing. Okay, then we will be finding areas and all. So you can see the bottom rectangle, okay, must have a length and breadth, right? Right. So area of the bottom rectangle will be L into B, right? Area of the top rectangle, which is exactly the copy paste of bottom, will also be L into B. Yes or no?
Yes,
Area of the this rectangle, which is standing on the side. Okay, area of this rectangle, here breadth is involved and height is involved. Okay, we are calling this one as a height. You call it anything. Okay, you call it breadth, height, you call it, like, we are having a rectangle which is standing on the side. One of the side is the breadth, another side is working as a height over here. But since it is a rectangle, height is there or whatever is there, area means this into that. Area means multiplication between both the lengths. That is, like, are you getting? Area means just the, even if the rectangle is standing and I am saying that this side is B and this side is H, area will be B into H. So what? Okay, rectangle means such a quadrilateral where opposite sides are same in length. Okay, there are two pair of parallel and equal side. Okay, it came from the parallelogram family, and here this will also be H, this will also be B. It doesn't matter, you are calling it length, you are calling it breadth, name doesn't matter. Okay, instead of B and H, if I will write A and B, area will be A into B. Instead of A and B, if I will write M in M and N, area will be M into N. Are you getting it?
sir.
Yes, Tejas, you can have. Okay, now similarly here also, this is just a copy paste of the same rectangle. So here also the area will be B into H. Please don't get confused. Area doesn't mean it has to be L into B. If one of the side is H, area will be B into H. Okay, so bottom rectangle, upward rectangle, left rectangle, right rectangle, all the areas we have found. Now the front rectangle and the back rectangle. Okay, the front one, if I will highlight, you can see here length is involved and height is involved. Can you see it? Can you see it?
Yes, ma'am.
Yes, ma'am.
Okay, length is involved and height is involved. At the back also length and height. So from here only the formula came. Okay, length into breadth, then one more length into breadth. Okay, breadth into height, then one more height, then one more length into height, and then from here only this formula came: 2 length into breadth, 2 breadth into height, 2 height into length, and 2 in bracket length into breadth plus breadth into height plus height into length. This formula came from here only. Area means surface area, total surface area means area of all the surfaces added together. Is it clear to all of you?
Yes,
Yes,
Yes, ma'am.
ma'am.
Now why we need to know it? Now why we need to know it? Because we are having a rectangle, okay, which is standing on the side. Okay, area of the rectangle will be L into B. Area of the rectangle will be B into H. Okay, now why we need to know it? Okay, we are good with the formula. We don't need that much detailing. So let me tell you why you need to know it. Suppose I will give you a box. Okay, and this time I am telling you this is a sweet box. Okay, where this upward lid is not there. Find the surface area. You are having such a box in which the upward cover is missing. Okay, I'm just showing you a open box. Take a sweet from here. Okay, you can also take, and then find the surface area of this box. Okay, where is this box? Is cuboid shape box. I'm giving you length, I'm giving you breadth. Okay, I'll give you length. Okay, as a 5, I'm giving you breadth as a 3. I'll be giving you height as a 2. Okay, and then I will ask you find the surface area. But keep in mind that the front opening is missing. It's not there. It's an open box. How you will find surface area if you have understood the concept? Tell me how you are going to find the surface area. All the surfaces are there except the top one. So this time what we will do, we will take the formula of surface area, length into breadth, breadth into height, height into length. But this is the total surface area. Here we need to subtract what? The top part area. We know the top part area is here. What is involved? Length is involved and breadth is involved. So L into B we need to subtract. Yes or no?
Yes, sir.
Yes, ma'am.
Okay, it requires proper understanding. Okay, that's why I was explaining you that from where the formula came. Okay, let's move. Similarly, surface area. Yes, Irshad, Farhan, have you got it?
Yes, ma'am.
Similarly, next shape is cuboid. Wait, cuboid we have discussed. Next is cube. Okay, next is cube. Now tell me, cube is made up of
Please.
squares. Okay, squares. Here length, breadth, height all are equal. That means the side of the square. All are just A over here. That means same over here. Okay. So here also we will be getting area like the previous case. Okay. This surface will be having area A square. This surface will be having area A square. This surface will be having area A square. Why A square we are getting every time? Because this is nothing but just a square. Okay. Squares are combined together. Okay. That's why here the area is A square plus A square plus A square plus A square. How many surfaces are there? Sazia says 6 surfaces are there. So 6A square is the formula for surface area of the cube. Are you getting it?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Yes,
Okay. Surface area, total surface area means area of all the surfaces combined together, added together. Now our shape, cylinder, which we are having in our syllabus. Cylinder is there, right?
yes, ma'am. Certainly.
Cylinder is there and cone is there. And a sphere is there.
Sphere hemisphere is there.
Yeah. Okay, so cylinder. Suppose I will take a A4 sheet paper. Can we roll it and make it a cylinder?
Yes,
Can
ma'am, we can.
we can make it a cylinder. This A4 sheet paper I can roll and I can give it a shape of cylinder. Okay. This A4 sheet paper was having length, was having breadth because it was rectangular in shape.
And height.
But once you will just fold it like this, make it a shape of cylinder. Shall I show it to you? Just a second.
After folding, we can also. There will be also height.
Yes. A4 sheet paper. See, length is there, breadth is there, breadth is there. I'm folding it. Can you see this breadth became the height of the cylinder?
Yes, ma'am.
Earlier, whatever was the breadth, it became the height. And length became circle. Can you see?
Yes, ma'am.
Yes, ma'am.
Length became circle, breadth became height. Circle means, see the border of the circle. That means circumference of the circle. Yes, the circumference of the circle. Length is working as the circumference. Can you see it of the circle?
Yes, ma'am.
Length is nothing but just the circumference of the circle. When you will fold it in the shape of cylinder, length will become circumference of the circle and breadth will become height. So previously your area was L into B, it will become 2 pi r into h. That means 2 pi rh is the curved surface area of the cylinder.
Yes. Yes.
Is it clear?
Yes, ma'am.
Okay. Curved surface area. What is curved surface area? This is curved surface area, the curved part. Only the curved part. See the curved part. This is the curved surface area of the cylinder. Okay, there are other surfaces also over here. Okay, this surface areas we have found the curved surface area. That is 2 pi RH. But apart from that, if I will attach a lid over here, I mean a lid over here, circular lid over here and a circular lid over there, that will give two more surfaces over here.
Yes.
Okay? If you will attach a lid over here and you will attach a lid over here, that means you are taking two more surfaces. Okay, and both are just the flat surface, that means circle. So this one area and this one area also we need to take when
2 pi r square h.
talking about the total surface area of the cylinder.
Yes, ma'am.
Total surface area means the curved surface area and also curved surface area 2 pi RH also, and area of the circles also pi r square plus pi r square. Are you getting it, everyone?
Yes, ma'am.
Yes or no?
Yes, ma'am.
That means 2 pi RH plus 2 pi r square. That means 2 pi r in bracket r plus h. This you will be getting. Basically h plus r you will be getting. But in general we write total surface area, which we write TSA also. Okay, of cylinder. Formula is 2 pi r in bracket r plus h. From where this formulation? We understand total surface area means area of all the surfaces added together. Okay, so we first, when our cylinder was hollow cylinder, we realized there is only one surface, that is the curved surface. But when there is a lid at the top and lid at the bottom, now there are two more surfaces, the circle on the top, circle at the bottom, and that is giving us this formula. Is it clear to everyone? Yes or no? Is it clear? Yes.
Yes,
Okay,
ma'am.
today you will be able to give the assessment from cycling